If you are a person who likes rules or steps to solve equations, here would be your steps to solve these problems using the zero product property, or ZPP, as I wrote up there. Your first step is to collect everything onto one side of the equation. Make one side equal to 0. It doesn't matter if it's the left or right side. All of your terms need to be on one side together. Whatever you have, you need to then factor it completely. After factoring it completely, each factor gets set to 0, and you solve those simple equations. Uh-oh! I want to solve this equation using the zero product property. However, I have a product, but it's not equal to 0. What I really need to do is get this side equal to 0, but if I subtract 12 right away, this stays the same, and then I have minus 12 over here equals 0. This is not a product. What I'm going to have to do is multiply all this out, that is, FOIL it, and then collect my like terms again. So here I go foiling. After foiling, now I'm collecting all my like terms. I have 2x and I have negative 15. This now is something more like what we were doing in the last video. I can factor this. Coefficient is 1, that makes my life easier. X here and x here. What multiplies to be negative 15 and adds to be 2? Positive 5 and negative 3. Using the zero product property, x plus 5 could be equal to 0, or x minus 3 could be equal to 0. That gives me the solutions of negative 5 and positive 3. Find an equation in standard form with integral coefficients that has this solution set. What they're asking us to do here is say that, well, I solved an equation using the zero product property and I got 1 and negative 5 as a solution. What was my original equation? Well, let's work backwards. If x equals 1 and negative 5, that means their factors must have looked like this. When I took them out of the zero product property, I needed to be subtracting 1 in order to get the positive 1, and I needed to be adding 5 in order to get the negative 5. That means that these are the two factors that must be multiplied together to get these solutions. Now the problem wants an equation in standard form. What they mean is they want it all multiplied out with the exponents of the variables in order. So that means we need to FOIL. First, outer, inner, last. Combine our like terms. Here is our polynomial in standard form. This equation has these as solutions. In this problem, we wanted to come up with the original equation. Find an equation in standard form with integral coefficients that has the given solution set. If these two are solutions to an equation using the zero product property, I could say that, well, if I pick the variable x, to get this solution, I must have had to subtract 2/3, and to get this solution, I must have had to add 4. Because this problem wants integral coefficients, if I FOIL this right now, I'm going to have a problem because I'm going to have some fractions involved with this one. What can I do to get rid of this fraction? Well, since it equals 0, I could multiply this side by 3, and this side by 3, well, keep 0 on this side, but when I distribute the 3 inside of these parentheses, my fraction will disappear. 3 times 2/3 is just 2. Notice, I'm just multiplying this first one by 3, not this one. There is no such thing as double distributing. If this 3 is in front, it's only multiplied by one of these, not both. So I'm not going to write over here 3x plus 12. I just need to multiply the one factor that has the fraction in it. Now, to finish up my problem, I need to FOIL this out. First, outer, inner, last. 3x squared plus 10x minus 8 equals 0.